Hello and welcome. In this video we are building a very simple paper trading bot with Python, including awesome real-time visualizations, as you see here. You will need some prerequisites for this video to better follow along, so please check out the video description. I list the necessary videos. Also, even though this is a paper trading simulation, this video is not an investment advice and the shown strategy is just a simplified example. The strategy itself is pretty much straightforward. Our bot is buying the coin whenever the price is above its mean price. So this red line is the mean price, and as you see, the mean is also moving as new data is flowing in. We are exiting the position once we made 0.3% profit or loss, which is enough profit to overcompensate the fees on Binance. This is of course extendable, so if you're interested in e.g. implementing some more complex strategies into this, let me know below. Okay, let's get started. First of all, we need a price live stream of e.g. Bitcoin. Therefore, I'm setting up the first notebook. This notebook is just getting live prices and writes them to a database. We need some libraries, pandas for data handling, SQL Alchemy for the database connection, and the Unicorn WebSocket API, the library enabling a live price data stream. So please make sure those libraries are installed. Then we need to define an engine, which is our database connection. So we are using create engine, and we are working with the SQLite database and give it a name, LivePriceDB. Then we are setting up the live stream by defining UBWA as Unicorn Binance Web Socket API Manager and define the exchange as Binance.com. After that, we have to exactly define what kind of live stream we want to have, and we are working with the 1-minute candlestick data. So let's create a stream. Take the 1-minute K-line data, provide the symbol, so in our case Bitcoin USDT, and we are also defining an optional argument here, which is simply providing us more readable data. So output is going to be Unicorn Phi. Now let's test that by defining data as UBWA pop stream data from stream buffer. And with that, we are getting data which is not yet containing valuable information. But remember this because we need to exclude those kind of data points which are also provided by the stream sometimes. So if you're executing that again, you will see that we are getting a dictionary containing the data we are interested in, which is K-line data on the 1-minute time frame. So what's important here, the event time is a Unix timestamp, and this is the time of the current price, right? So this K-line start time is the opening time of the candle, and the K-line close time is the close time of the candle. So if we have a non-closed candle, so is closed is false, this is an intra-candle price tick. So this Unix timestamp will be somewhere between those two timestamps here. All right? So when this is true, so is close is true, then the event time will be the same as the K-line close time. All right? Now what's our current price? Our current price of this event time is the close price. All right? And every time I'm executing this, I'm getting new price data or new K-line data here, right? So what do we need to do? We can just execute this one here in an infinite loop, right? So we are defining while true, pop data from the stream, and then we just have to exclude two situations here. So first, if data in general, because data can also contain nothing, so that this is a non-data type and we want to exclude that. So if data ensures that we have actually data, and we also want to exclude the one data tick which you saw in the very beginning when we were executing this the first time, and simply I'm just defining and length of this data is larger than 3, because then we are excluding those non-valuable data ticks. Okay, and if that's the case, we want to print data. Let's get rid of this for now. And if we are executing that, you will see that we are getting a live stream of 1 minute K-line data, right? And the next step will be now that we are using this dictionary type of data, transform that to a data frame, and write this data frame into our database. So let's restart the kernel for now. Execute this again, this also, and this also. And now we want to define a function which is transforming the data to a data frame and is also writing this data frame to our SQLite database. So let's pull data once again, that you understand what I'm doing in my function which I'm defining now. So this is our data, and I'm defining a function SQL import now on incoming data. So first of all, I'm defining a time here, right? And my time is simply my event time, and as this is a Unix timestamp, I want to transform that to a human readable timestamp. So I can do that by using pd_datetime, provide the timestamp here, and define the unit as ms, and you will see now we're getting today and 11:40 here. All right. So I'm doing that in the function by doing pd_datetime data event time. So this is simply accessing this here. So I'm getting the Unix timestamp, right? So I'm going to show you step by step. So event time is getting me the Unix timestamp. So I have that and need to provide unit as ms, getting a human readable timestamp. And then I'm defining the close price, which is contained in the K-line dictionary in this dictionary here. So you see here is a new dictionary K-line, and then I'm accessing the close price. So I'm just using data, access the K-line dictionary, and then access the close price. As this is a string format, I'm going to show you. You see that here, there's a string. I want to typecast that to a floating value as well. Float of that. And now I have my timestamp and a close price, and I'm going to wrap that into a data frame, right? So I'm just defining frame, pd data frame, define a column timestamp, and take my time value as the values, define a price column, and take my close as the values. And I'm also defining an integer index here. And after that, I'm taking this frame. So how does this frame look like? I'm going to quickly just show you, execute that on the global level. So the frame is looking like this. And this is the frame I'm going to import to our SQL database. All right. So doing that with toSQL. Now I'm just taking the symbol. So symbol is just Bitcoin USDT. As you see here, if I'm accessing that, and this is my table name. So Bitcoin USDT is my table name in the SQL database. Provide the engine so that Python, or rather pandas, knows where to write that in. Set the index to false. And if that table exists, very important, I want to append, because I'm doing that. Every tick I'm getting, I'm writing the data frame to our database, right? So every second I'm getting a new row in this data frame. So I'm appending a new row in the data frame. Okay, so if I'm executing that, I've defined my SQL import function, and simply instead of printing here, I can just take SQL import of the data, and then I'm getting live prices stored in my live price DB database once I'm executing that. So let's do that. And now a new database has been created. So let's open up a new notebook here. And now we are going to access this database. So we need some libraries, going to copy paste that, create engine, and we also need the engine from this notebook. And now I could access the data simply by taking read SQL, provide the table name and the engine. And with that, I'm getting the stored data. Your data frame will probably have fewer rows. I simply messed up the recording here and some minutes were already passing since I started the stream. But anyhow, if I'm executing that again, so you see 2, 6, 5 rows now. If I'm executing that again, I'm getting new rows here, right? As this is being live updated every time a new price is floating in, right? Now let's visualize that. Therefore, we have to do some amendments to this notebook. So first of all, let's get rid of that for now. We need to take matplotlib notebook, otherwise it wouldn't work. We need to also import matplotlib, and we need to import matplotlib animation as animation. Right, now we need to define a function. I've already covered that in one of my previous videos, and I will link an article explaining that very nicely in the video description. So I have to define a function here, animate poll data using read SQL, table name, and engine. So this is the same as df, right? This is simply this data frame with those 2 columns, timestamp and price. And now I'm clearing the axes every time, plotting the timestamp as the x-axis and the price as the y-axis. And I'm also giving that a color green here. Now I need my horizontal line you saw in the beginning, and this is simply my price mean. So I'm taking horizontal line and define that as my mean price and set the color to red. Labeling it, X label will be time, Y label will be price, title will be BTC USDT, saying GCF. So I'm not explaining what I'm doing here because I've covered that in my other video. This is simply just making it possible to plot the live chart. So animation function created, defining any as animation dot func animation plt GCF, provide our animate function and then the interval of update in milliseconds, define title layout here, and then finally show the plot. So this is providing you the plot you saw in the very beginning, right? So let's take a look at that. Not seeing anything here. Okay, because I took the wrong table name here. Okay, so let's execute that again, and now we see we are getting the live plot of Bitcoin. So you see this is actually moving, and this is also moving. All right, and now let's define our strategy. So you can do that in this notebook, but our strategy will work with loops, and whenever you are executing a loop, this live animation will stop, right? So I recommend to open up a third notebook here. So we are keeping this so that we can observe what's happening. Maybe we are lucky and we are hitting a trade here. And now we define our strategy in the third notebook, right? So we need pandas and create engine again, because our strategy needs to access the data from the database. Need the live price engine again. And yeah, then we can define our position, not position, our strategy. So we are first setting the initial position to false. This is simply tracking if we are in a position or not. And now we are endlessly looping, pulling data from the database, which is being live updated once again. And then we are taking the last price here, and the last price would be the last row in this data frame, right? And to get the last row, we can use df price ilog -1, and with that we would get this value. This is our last price. And now we are checking if we are not in a position. We want to check if our last price is above the mean price. And if that's the case, we want to store a buy price, which is our last price. And with that, we are in a position. And we can get a feedback here that we bought for and provide the last price, which is our buying price, or rather bought for buy price here. Okay, and then we are defining if we are in a position now, which is the case when we are entering a trade, because we are setting in position to true. And if that's the case, I want to say if last price is above 0.3% on top of the buy price, so this is our target profit, or so this is our stop loss, our last price is below 0.997%, not percent, but 0.997 of the buy price, then we are defining our sell price as the last price and set in position to false. And then we want to have feedback sold profit is, and then we are simply calculating sell price minus buy price. Okay, so let me go quickly over that with you together. So our initial position is false. Then we are endlessly looping. So we are just pulling new price data, right? We are pulling a data frame infinitely here. And we are always checking the last row. And if we are not in position and the last row is above the mean, that would be in visual terms, if this line is above this line, we are buying, right? And then we are storing the last price. So if this condition is true, we are storing this last price in a variable buy price and setting the in position to true to get to this if in position code block, right? And now we are just checking if the last price, which is always the last row of the pulled data frame, if that's 0.3% on top of the buy price, we want to sell, as we made 0.3% profit, right? Or if it's dropping, we made 0.3% loss, we want to exit the position, store the sell price, and then calculate the profit by simply subtracting the buy price from the sell price. Okay, so let's execute that. Maybe we are lucky in making some trades, so maybe the Bitcoin is rising in some seconds if we are lucky enough. So let's execute that. And now you see we are crossing the mean. So we should get a feedback that we bought, bought for, and now we are tracking the price where the Bitcoin was in that moment. And now if this is either dropping by 0.3%, we are exiting the position, or this is rising by 0.3%, we are also exiting the position. In one case, we made a positive profit, in one case, a negative profit, right? So this will probably take some time. Okay, so after quite some time, the trade was closed, so we made a slight profit here. What you also notice is that we directly enter the next trade as the coin is currently trading above the red line. So what could be improved or even extended? You could just buy whenever the green line is crossing above the red line instead of the green line being above the red line in general, right? Additionally, you can store the trades, e.g. in a CSV or also in an SQL database. You can work with support and resistance lines instead of only the mean. You can work with technical indicators. The possibilities are endless. So let me know what you would be interested in. Thank you very much for watching, and I'm looking forward to seeing the upcoming videos. Bye bye.